It is now my pleasure to turn today's program over to Mr. Michael Myrick, Marketing and Training Manager with MCR Safety. Michael has been with MCR Safety for 15 years and in the safety industry for 24 years. Sir, the floor is yours.
Thank you very much, Dennis. I want to welcome everybody this afternoon to this webinar. We're going to cover a lot of information in a very short period of time, but I know that a hot button issue right now in the industry wide is this new impact standard. And so what I want you to take away from this today is what the standard is, what it's going to mean, and really how it's going to help you and I in the big scheme of things when we're talking to end users about their impact needs. Excuse me. So let me go through some information about what the standard is. ISEA started a working group back in 2017. Now, ISEA is International Safety Equipment Association. Most of you are probably familiar with them. And ANSI is American National Standards Institute. They work together to write and to solidify these standards, whether it be cut resistance standards, the whole glove 105 standard, or in this case, focusing in on a specific category like impact. Now, they consulted with research facilities, hand surgeons. Actually, part of the testing was using cadaver hands to actually find out how much pressure, how much energy, kinetic energy did it take to actually crush bones and crack bones. And so all of that data was put together to try to write a standard where now, and I've always called the back of hand kind of the forgotten zone, but now you can actually take it and be able to focus on this back of hand protection like never before. If you've been in the industry a long time, you may be familiar with years ago, the mining industry focused a lot on back of hand protection, but nobody else really did. And now we want it to be across the board. Now, there's going to be 3 performance levels. It's going to be judged on the back of the hand, on the knuckles, as well as the fingers. And actually, I just found out about 20 minutes ago that one point on my screen is inaccurate. It says that the ANSI ISEA 138 was approved and active on 3/15. That's actually not correct. It was February 21st when it was fully put into place. And so February 21st of 2019, and all of us manufacturers have a year to come under compliance with this. Now, we worked directly with a company called D3O, and that O being an O for orange. But D3O, to look at what would be the best type of materials to be used, what would pass a test without having to be real thick and real uncomfortable materials. And so what came out of it is a way of actual testing each glove. Now, what happens in the testing process is the glove itself, the back of the hand is removed. So that sample you see laying, it's actually laying on the carpet there, but on the left side of your screen, that is having the hand part, the palm part of the glove removed. So the back of the hand is the only thing that's tested. So nothing messes with the scoring. So on the thumb, on the index finger, and the ring finger, it's tested 25 millimeters from the top of the glove. On the middle finger and the pinky, it's going to be 50 millimeters from the tip of the glove. Now, that's from the tip of the glove, not the tip of the material, okay? So tip of the glove. The knuckles, as far as how they come up with the point on the knuckles, is they actually have 3 different people put on this glove. So it'd be a size large. You had 3 people who wear a size large. They put the glove on. They make a fist around this tube. You see that tube that's next, that gray tube next to the picture on the left. They put their hand around that gray tube, and where the points of their knuckles are marked on that sample. And then a triangle is drawn, and the center of that triangle is where the testing is done. Now, why do I tell you that? Well, one of the things that I'm always real cautious about when it comes to testing is it a true test, or is there ways to manipulate the test? And that's one of the things that the ISEA group came up with. Let's look at ways to where you really can't manipulate this test. It's not going to be just straight across one place or straight across another. It's going to be tested in different areas. And notice this test includes the fingers and the thumb, where if you may be familiar with the European impact standard, it's just the knuckles and it's just a pass or fail. This is given a performance level based on the amount of energy that on the test protocol, that the amount of energy goes through that glove. So less energy going through the glove, then the higher the score. It's kind of like golf, okay? The lower the score, the better you're doing. All right, so in this situation, performance level 1 is going to be less than or equal to 9 kilonewtons. Now, that's not a normal term that you and I probably use on a daily basis. You may, I don't. All right, so we're not familiar as much with kilonewtons. It's more of a scientific way of looking at it. Here's where you and I kind of can understand it. It's going to be 3 levels. Number 1 is going to be the lowest level. Number 3 is going to be the highest level. Now, here's where it's really going to help. I've talked to a ton of people over the last few weeks about the standard, about cut protection standards and things like that. And one of the things that I love about this standard is the ISEA working group and ANSI agreed that if it is going to be truly an impact glove, if it's going to have an impact performance level, that information has to be found on the glove somewhere. Most of the time, these are going to be multitask type gloves, so not a real good place to put it on the outside. There'll be included a information tag on the inside, which will include, if you see those ANSI ISEA 138 icons, those are going to be on the inside of the glove on a tag. So this gives the wearer an idea of when you put that glove on, you can look at it and see what that impact level is. Now, the other thing that's going to help you and I is folks that are coming in trying to sell a cheaper product, and you say, well, what's the impact level? You say it's an impact glove. What's the impact level? Oh, you know, we hadn't had ours tested. Or, you know, we really don't know what the impact score is. Well, you know right off the bat that's not an impact glove. From this point forward, from 2/21/19 forward, if you say or you advertise it's an impact glove, you have to have the impact rating, the data on your website, on spec sheets, on flyers, whatever, and you also have to have it on the glove. So that's going to be really helpful. So how do they do the test? They actually have a drop test. That material drops down and it hits in those spots that are designated for that test area, whether it be the fingers or the thumb or whatever, and then a peak transmittal force number is given. Now, I don't want to geek out on you completely. I know it's afternoon on a Friday. Some of you really would rather be on a golf course than talking to me right now, but just to give you kind of a nutshell, what happens is this mandrel drops down and it hits, and underneath there's an apparatus that's attached to a computer. It's going to measure that force and give that number to a computer. So what's great about this is there's no way where somebody can say, oh, that didn't hurt as bad, so it must be a 2. Or that really hurt, so it must only be a 1. This is going to be information that's going to be calibrated and tested via a computer. All right, so when you look at and compare different materials, TPR, which is thermoplastic rubber, is the most common used right now in the industry. EVA foam is another material that's used for impact resistance. Porine XRD is used for a lot of impact resistant materials. But if you look at the comparison with the D3O, you take the same thickness of D3O material and you compare the transmitted force. This is the force that goes through the glove. This is the force that you want to stay out of the glove, okay? When you are hit on the back of the hand, you want the material on the glove to accept the energy, not push it through to your hand. The D3O is going to, on a 4-millimeter material, is only going to allow in about 7 newtons of material, or excuse me, of energy, versus a TPR or an EVA, which is going to be a greater number. Now, How does that translate down to gloves? If you take our MCR Safety Force Flex glove, you have the D3O on it. You look at the thickness. So there's 2 bars on there on each section. The first bar is the peak transfer force. The second bar is going to be the thickness. One of the things that you will notice is there are multiple different gloves there that have a really thick material, and that really thick material is going to give a low peak transfer force. But that's what most companies are having to do, is make their material thicker in order to meet this standard. I was at a trade show back a few months ago, and one of our competitors came out with a level 2 impact resistant glove, and I'm not exaggerating with you at all. The material on the back of that glove was 2 inches tall. It's not what anybody would want to put on their hand and wear all day, okay? You're talking about, it seems like a 5-pound glove when you put it on your hand. So the goal is to be able to try to create a material, like with D3O, a material that's going to be thinner, not have that big, thick, bulky, and still be able to hold back that peak transfer force. Now, we're a very large company. We have a lot of technology behind what we do. We're talking about a very technical thing, and then I'm about to show you a video that literally I shot at my desk with my phone. Was trying to figure out a way to show you visually what a good impact resistant material and a bad impact resistant material, or not a bad impact, but a lower grade impact resistant material is going to react to just a dropped ball. So pay attention to the material on the left, the orange, which is D3O, and you'll see that the ball comes down, it's going to bounce once, and then it just stops, okay? So what that material is doing is that material is accepting that energy and spreading it out instead of pushing it in so many different directions it bounces all over the place. Now with the TPR, you saw that. That just kept bouncing and kept bouncing and kept bouncing, okay? So we'll show that again. That is going to be the most common thing that you're going to see in the industry. That TPR material, it does hold back some of the force, but it's going to keep that force going through to your hand versus a D3O material, which is going to take that impact, going to spread that out, okay? So how does that transfer over to gloves? When you look at the different gloves out in the industry, and I'll tell you this, there's not going to be a lot of level 2 and level 3 products out there that are very comfortable. Just going to be honest with you. We have a level 2, our FF2930 Force Flex. We had it field tested by Exxon, with BHP Billiton, with Kodlak, Kodlaco, lots of different companies that we had to look at this glove. And the one thing that they said over and over again was it was the best combination of performance and dexterity available out of all the different gloves that they were testing. Now, what we did with this one, for instance, we had the knuckle impact dissipation to be 54% better than our competitors, while being 57% thinner. What does that mean in layman's terms? Is instead of creating a really thick glove and a really uncomfortable glove just to add impact protection, we've added a material that was soft and flexible and thinner so that you could work in it, not want to take the glove off, and provide that impact protection. Now, it is a level 2 impact protection. If you look at the level 1 options, that really spreads out. Okay, we've got a lot of different level 1 options, including some welding options that have level 1 back of hand, including a fully dipped chemical glove and our Ninja Alchemy fully dipped chemical glove that's going to have a level 1 back of hand, as well as a lot of the others on the screen. Okay. The last material that I'm going to show you is our non-impact options. You say, well, why in the world, if we're talking about impact protection, why would you show us non-impact products? Because quite frankly, you're going to see a lot of redesign in the industry, including some of these that you see on your screen. Why would they need to be redesigned? Well, because if they don't even meet a level 1 impact glove, you can no longer call them an impact glove. Okay, so we're going to do some redesigning. You're going to see a lot of that in the industry, a lot of turnover. You're going to see a lot of different configurations. And one of the things that you're going to see that's kind of change a lot of things is you're going to see a difference between sonic welded products and you're going to see sewn material. Now let me just tell you the basic. When you first hear the difference between sonic welded and sewn, most people teach it as sonic welding is not going to have any seams, sewn material is going to have seams, so it's going to be uncomfortable. It's true and false, okay? Sonic welded, like what's on the back of our Predator series gloves, whether it be the Predator Multitask or the Predator knit gloves, sonic welded material is going to adhere to the material of the glove. Now, years ago, some of you may remember back when TPR first started being added to gloves, a lot of sonic welding would not hold onto the gloves, and you'd see it peel off a lot, okay? And you're not going to have that now. Technology has changed. Just like, honestly, if you look down at your phone or your computer you're dealing with, the amount of information that will be pushed through our phones or our computers today would have been a whole room full of computers back when I first got in the industry 24 years ago. So times changed, so has sonic welding. So it is an advantage. You're not going to have seams in there. It's not going to rub. It's not going to chafe. It's not going to wear out. But on the sewn material, don't automatically disqualify it, because a lot of sewn material like D3O a lot of times has to be sewn on there because the sonic welding sometimes will break down the material. So the sewn material is going to be stronger holding on there. It's going to be certain materials cannot be welded, so they must be sewn. Now on cheaper products, honestly, cheaper products, yes, the sewing can be felt on cheaper products, okay? So when you look at some of the products in the industry that compare with sonic welding, on your lower priced options, I'd use cheaper products out there, those sewn edges will rub your knuckles raw, okay? What we do on most of our, especially mid-grade and higher grade products, is we'll put a liner in underneath that sewn material, and that way you don't have that issue. Okay, so like our Force Flex FF2930 is going to have that situation. Okay, now a couple of different things that I want to make sure that we cover. Just about out of time, and going to open it up for questions. But one question that came along is level 3 and level 4 available. Keep in mind this, that level 3 is the highest level of impact resistance. Level 4 it's not out there yet. Maybe down the road we may be expanding it, or the ANSI ISEA may be expanding it. I have not seen many level 3 gloves, because like our D3O option, the knuckles are level 3. The fingers are level 2, so you have to go with the lower number. And so the thickness of the material has to be pretty big. I think what you're going to see over the next few years is just like we've seen in cut resistance, there's going to have to be some advancements in materials in order to keep those materials thin and still be able to meet that impact level 3. So no 3s and 4s available. I will say this, I'm trying to keep this more focused on the standard and that information, but just for an FYI, the Force Flex FF2930, there will be a cut resistant offering of that mid-May is when it's going to arrive here. The FF2931 is an A5 cut resistant version of that same glove, so just kind of an FYI on that. Now, I know we went through stuff really fast, and I want to make sure that I stayed within the time frame I was given and honored that. I want to thank you for your time, and at this point, we'll open it up for questions.
As a reminder, you may ask a question through your web console. Locate the Q&A panel on the lower right-hand side of your screen. Type your question in the open area and click Send to submit. If you would like to ask a question over the phone, simply press star, then the number 1 on your telephone keypad.
Just wanted to jump in. My name is Rebecca Avery. I'm the Category Strategy Manager for Safety here at MSC. I just wanted to give a very big thank you to Michael and to MCR for hosting this webinar for us today. they're a great partner of ours, and we really lean on them when new, new standards come out and new things come out in the industry. So again, thank you so much, Michael. Just wanted to give you guys a quick background of Better MRO. So recently, about a year and a half ago, MSC stood up a content site that we call Better MRO. It is separate from our commerce site, which is mscdirect.com. It's all about educating the end user, right? So things like this, webinars. This webinar will be taped, and you can play it back for your colleagues and anyone else that you want. We also have past webinars that we've done in the past. Any new webinars that come up, we're going to do them once a quarter. Infographics, articles, white papers. We have product selectors, injury cost calculators. There's a bunch of great information on there. So I please encourage everyone to please visit the site, and that's mscdirect.com/BetterMRO.
Again, everyone, you can ask a question over the phone by pressing star, then the number 1 on your telephone keypad, or through the Q&A panel on the lower right-hand side of your screen.
Hi, this is Jeff Cohen. I'm a category strategy manager for MSC as well. Can you please, Mike, describe the sonic welding process to us and the adhesives that are used to actually attach the TPR or D3O, please?
All right, absolutely. Yeah, it's it used to be basically a peel and stick. Okay, you had a adhesive material on the end or the outside of the TPR, and then it was laid on, and it was more just hope that that adhesive stays in place. The way it's done now is that adhesive is applied to the back of the TPR, and it's laid on, and then it is heated. Okay, so it's heated to where the material of the TPR actually, I hate to use the word soaks in. I'm trying to find a better term for your answer there, Jeff, but soaks into or becomes a part of the material. And so that's why it's so hard to separate from it. Very, used to, like I said, with that adhesive, you could just peel it off. But now that TPR becomes a part of the glove. And so it's very, very difficult to remove it. And so that's one of the reasons why there's a lot of sonic welded material out there, and TPR is a great example. EVA foam, you have to kind of put an encapsulation around it and sew it. D3O, most of the time you're going to find D3O is going to be sewn around the edges, and it's going to be sonic welded and then sewn as well on some different gloves that I've seen. But that sonic welding, the material, the TPR material or D3O becomes a part of the glove. It actually goes into the fibers. I hope that answers your question.
Yes, it did. Thank you very much.
And Mike, we have a few questions that came through the Q&A box. So Tim asked, how do you determine if you need impact-resistant gloves?
That's a great question, and really it's one of those. I hate to say it, almost seems simple. Is if you ask the end user, are you having people that are getting bruised on the back of the hand, or have you had any crush situations? Because a lot of times crush is just a factor of something dropping on the hand and a couple bones being broken. I know that may sound like an easy way of putting it, but and they call that a crush. Well, that's really not a crush. That's more of a situation where a back of hand protection like a D3O or TPR would have taken care of that. So a lot of times just asking, are your employees complaining about having bruises on the back of their hands? Are you having people who are having lost time off injuries because of injuries to the back of the hand? I will tell you this, if they're working in oil and gas, if they're working in a lot of construction, if they're working in lumber industry, pretty much those industries, they're going to have back of hand protection because it's a very commonly injured area. But ask for their OSHA 300 log. That's a public document, and you can actually see where some of the injuries, what part of the body some of the injuries took place at. And if it's back of the hand a lot, then they definitely need some impact resistance. And, tied to that, a lot of times people ask us, what level do I need to start with? Really, if they're just just having some bumps and bruises, I would start with a level 1, absolutely. And then I would, but if they've had quite a few broken bones, some people missing time over some really bad muscle bruises and things like that on the back of the hand, then I would definitely go up to a level 2.
I wanted to ask one more question. This is Jeff again. What industries would you recommend what impact levels? So would you say like general construction maybe would be a level 1, and maybe like oil and gas would be either a level 2 or 3? Can you elaborate on that, please?
Absolutely. You answered a lot of the answer right there. Your general construction, your general industry situations, your lumber industries, plumbing. I was a plumbing safety director for a plumbing company for a couple of years. Plumbing is a big industry. Iron workers, where they're getting the metal rolling on the back of their hands. That's a level 1. That's just that's bumps and bruises is what I call them. The oil and gas industry, they are definitely going to be using a level 2 impact protection. If they're not, they need to be using a level 2 impact protection. And when we say oil and gas, keep in mind that translates to a lot of different, whether it be the oil and gas transportation, whether that be the main lines, whether that be any section of it. They're dealing with a lot of pipes, and they're dealing with a lot of machinery, and so they're going to have, just like what's actually pictured on your screen, this guy's having to use a hammer to break this this hose off to be able to twist that hose. So you have those opportunities. So your heavier industries like your oil and gas, if they're doing a lot of one industry, we got a lot of feedback on the level 2 impact was the concrete industry. A lot of areas where they were laying blocks, where they were running a lot of rebar, and so a lot of bad back of the hand injuries happen with that. So I would say level 2 on heavy construction, concrete work, oil and gas. Level 1 would cover a lot of other the industries.
Perfect. We have another question that came through the chat box. Alan asks, could you talk a little bit more about the KN measurement and just get a little more granular in that? Not sure if it was understood completely. On
the hand measurement?
The KN measurement, I'm sorry.
Okay, sorry. No, I just making sure I was hearing you correctly. This is measured in what's called kilonewtons. Kilonewtons is a measurement of energy. Most of the time I get the request a lot of how do you calculate that over to PSI. You know, my hydraulic machinery operates at 6,500 PSI. Which impact glove do I need? And really the kilonewtons is an energy transfer, PSI is a pressure transfer, and so the two don't really play well in the same together. And so kilonewtons is just the scientific unit of measure, and that's the amount of force that is measured that goes through the glove. So that mandrel drops at the same rate every time, no matter what glove is put on that device. And so the amount of kilonewtons is the energy that's transferred through the glove to what would be the back of the hand, which is the other part of the testing apparatus.
Perfect. We have 2 more questions that came through the chat box. The next question is, I apologize, I'm just trying to scroll up and make sure I see all of them. In the automotive repair industry, does OSHA use standards for hand protection, or are we trying to prevent issues?
I think the best way to answer that is OSHA really doesn't, OSHA's view of it is that safety directors should use all available technology to determine what they need for protection of their employees. The only time I really hear OSHA talk about these standards specifically is after an injury has happened. And then they come in and they say, well, they had a back of hand injury, what level impact resistance were you using? And they kind of use it in that mode. They don't really refer to the ANSI ISEA 105 or this new 138 standard until they're going in doing an investigation. So this is more of the tool for the safety professional to use to determine what level of protection that they need.
Great. Another question that came through, and I think this actually rolls into a couple of different questions that were asked. Are there any level 1 protection gloves with also cut protection built in? Another question that came through was, are there gloves that have the impact protection as well as cut and puncture? So are there gloves out there that kind of do a 3-in-1?
Yeah, absolutely. We already have a few options within our line that have cut resistance and level 1 protection on them, and in our Force Flex series, as well as some new welding options that are out, and what was originally our Ultratech series, which had 3 or 4, my brain's going dead this afternoon, 4 different options with cut resistance. They're being redesigned, and so they'll be level 1 by the end of the year. And then the level 2, the Force Flex FF2930, yes, there'll be an ANSI level A5 available in that mid-May of this year.
Got it. And then the last question that came through, what would you recommend for a machine shop that does a lot of grinding and changing of inserts on machines?
With that, I would always make sure, because of the grinding, you're going to need to go with as much natural leather as possible. So on our level 1, we have some MIG-TIG styles that 48406 is the part number that have level 1 impact on the back of the hand, and then they're full goat skin on the palm and cowhide on the cuff. So that would take care of the grinding, and then that level 1 impact would give them the impact resistance on changing the inserts.
Perfect. Okay. Well, any other questions that you guys have, please be sure to direct your sites to mscdirect.com/VetterMRO. As I mentioned earlier, a recording of this webinar will be available in the next couple of days on the site, and you can leave a comment asking questions, and we'll have one of our MSC safety specialists or Mike reach out to you with an answer. So thank you all again very much, and that concludes today's webinar.
Thank you.
Ladies and gentlemen, thank you for joining today's webinar. You may now disconnect.